Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled The Retrograde Dance of Saturn and Neptune. So, what do we see here? Well, here we see multiple images of two planets in the sky, and that would be the planets Saturn, the brighter one towards the middle of the image, and Neptune, the very faint loop up above. Now, they're both labeled here for you to see, and these images were taken over 34 different nights between May of 2025 and February 2026. And what we're seeing is the retrograde loop of these two planets. Now, a retrograde loop like this occurs when the planet, like these, are at opposition. They're at the opposite direction to the sun in the sky. That's when they are most visible. They're up all night long. It's kind of like the time when the moon is full. It's opposite the sun. We see the full moon all night long. Well, when Saturn is at opposition, it rises as the sun sets and sets as the sun rises, being up all night as well. Now, the loop is actually because we are passing it in our orbit. Our moon does not form a retrograde loop. It always moves in one direction through the sky. That's because it's orbiting directly around Earth. These planets are orbiting around the sun just like Earth does. So Earth is closer to the sun than Saturn or Neptune. It moves faster, and as it passes them in the orbit, it will then make them appear to be temporarily going backward. And that's what we're seeing here in these images. You can see up at the top middle there, where the little arrow is, it shows where it's starting, right in the middle, right above where it says Saturn, and then it heads off toward the upper left, reaches a point there in Pisces, stops, turns around, and heads back down, crossing into Aquarius, before it stops again and turns around and heads back to the upper left again, and therefore continuing its normal motion. Now, again, the retrograde loop is because we're moving as well. And this was a difficulty for astronomers to understand thousands of years ago when we thought that Earth was still. Planets shouldn't do this if the Earth isn't moving. So we came up with the concept of an epicycle that allowed the planet to make a path like this. So we had to come up with a model that fits the observations. This is the observation. This is what we see, what the planet actually does in the sky. We could then take that and make a model that fits. Now, of course, our models at the time, thousands of years ago, were that Earth was at the center and unmoving. So we had to go with what we had there, and therefore the planet had to be making this little loop to match the motions that we see in the sky. Now we know it's just Earth passing the planet, making it temporarily appear like it goes backwards. So we pass it, it looks like it goes backwards for a couple of months there, then it stops again and starts heading forward. We can see the different sizes of the loops, that Saturn's, not just the object being much brighter, but also makes a much larger loop in the sky. It's a little closer to Earth than Neptune, which is much fainter up above. Neptune being very hard to see because it is so faint. Now, the difference in here is that all the stars stay the same, and those were the fixed stars long ago, whereas the planets wandered among the stars. So not only did they make this retrograde motion, but they also moved among the stars. They changed their positions, and that's what gave them their importance to early astronomers. So that was our picture of the day, titled The Retrograde Dance of Saturn and Neptune. We'll be back again tomorrow for the next picture, previewed to be spiraling into a supernova. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.